Hi everyone, let's try attempting another June LeetCode challenge problem. This is called largest divisible subset, and the problem statement says given a set of distinct positive integers, find the largest subset such that every pair Si of elements in the subset satisfies Si modulus Sj equals 0 or Sj modulus Si equals 0. So basically, for every pair, one element should be exact divisor of another. So I think all these examples are pretty small. I actually have got one example with larger data set. So say in our array, we have all these elements and considering this particular subset, we can see that 20 for 20, 1 is its exact divisor. So this satisfies our set criteria. If we talk about this, for 4, 1 is its exact divisor. For 20, both 4 and 1 are its exact divisor. So this one also satisfies our criteria. So there would be many more such subsets, like we can create one right now. So there would be 3, there would be 6, 12, right? And many more. But considering all the subset, this one is biggest, this one is largest with most elements. So we have to return this particular subset. Now, how will we implement this? I'm going to provide a solution using dynamic programming. Let's look at how we are going to implement it, and then we'll actually implement the solution. So basically, first of all, we have to sort our array so that for every element, its exact divisor are ahead of it. So we will first sort the array, and we'll also try to find the complexity right now. So if we sort the array, the complexity would be n log n, right? And now after sorting the array, we need if you know dynamic programming, so you might be aware that in dynamic programming we divide a larger problem to smaller problem, and then solve all our smaller problem, and in the end, using those small solution for small problem, we build up our solution to largest problem. So in this case, our smaller problem would be um, getting the largest subset at particular index. So we will create another array called dp array, which will store a solution, which will store the solution at any particular point. So length of this array would be exactly equal to array size, because that's the maximum number of smaller subproblems. And then we will have another array called index array, which will store the result at which index we actually got this solution. Okay, so then we will start a pointer I starting from array index. And now you might be wondering that why dp array is initialized 1 1 1 and index array is just initialized -1. So if we talk about a single element, it would be obviously divisor of itself, and if we add that element to our subset, it's already giving us subset of size 1. So we need to initialize our dp array to 1. And then since we haven't found out the solution to this particular index, so we are initializing our index array to -1. So now we will start a pointer I from first element, and there are no elements behind it. So and so we can't actually find out any exact divisor for this element. So we will move on to the next element, 3. And 3 is actually exactly divisible by 1. So we will update dp of 3 by dp of element that is its exact divisor plus 1. In case dp of 3 is smaller than dp of element that is exact divisible plus 1. So we will update it to 2. And what is the index that we got this result? Index of 1, right? So that is 0. So we will update index array 0. We will also update maintain maximum and maximum index. Maximum would give us maximum subset achieved till now, and maximum index would be where did we got this subset, maximum subset. So currently, initially our maximum would be 0 and maximum index would be -1 because we haven't found out. But now for 3, um, as the solution is greater than maximum, so we will update this to 2, and maximum index would be updated to index of 3, that is 1. Now we will increment our I to another next element. For 4, it is not divisible by 3, so we will try another. It is divisible by 1, so and a dp of 4, which is 1, is actually smaller than dp of 1 plus 1, that is 1 plus 1. So we will update it to 2, and so we found out the solution at 0th index, so we'll update this to maximum is not greater than but the solution we achieved just now, so we won't update it. Now we'll move our I pointer to next element. um, 6 is not divisible by 4, but 6 is divisible by 3, and so it means we might have to update our dp array. Let's check if dp of 3, that is dp of 1 plus 1 is greater than or greater than dp of 6 or not. So that is 2 plus 1 is greater than 1, right? So we need to update our dp array, and we need to update our index also. So we'll update index to 1. Now we'll move on to next element 1. 1 is exact divisor of 6, but it is giving result as 1 plus 1, 2. But 2 is not greater than 3, so we won't take that and update our DP array. So now we are out of elements. We'll see if our current maximum is greater than DP array. Yes, it is. So we will update maximum to 3. And our max index would be, where did we receive the solution? At 1 index, so we are updating it to 1. Now let's move on to the next element, 9. 9 is not exact divisor of 6, 9 is not exact divisor of 4, 9 but 3 divide 9 exactly, so we'll update the result to 2 plus 1, that is 3, and index where we got this result is 1. uh, but our max is not greater than the solution we just received, so we won't update it. We'll move our I to next element. 12 is not divisible by 9, but 12 is divisible by 6, right? So we will update this to 4, and our index would be 0, 1, 2, 3, index of 6, which is 3. um, 12 is divisible by 3 also, but it will give us result 3, which is 2 plus 1, 3, which is greater than our current result, so we won't update it. And this solution is actually greater than max, so we will update our max to 4, and our index would be updated to 0, 1, 2, 3, 4, 5, right? Now talking about 20, 20 is not divisible by 12, not divisible by 9, not divisible by 6, but divisible by 4. So that is a 2 plus 1, which actually result in 3, or which actually result in 2 plus 1 is um, 3. So we update our DP array to 3, and our index is updated to 2. But this is not greater than current max, so we won't use it. Now, where will we use this max and max indexes? While putting this element in our result set. So we'll start from maximum index, which is 5. So what is the element at 5? It is 12. We'll put it in a result array. And what is the index at what is the value in index array for 12? It is 3. So we'll jump on to third element in our array, which is 6. We'll put this in result. What is the value in index array for 6? It is 1. So we will put 3 in our result set. What is index array value? 0. So we will put element 1 in our index array. So this would be our output. Now let's try implementing it. Okay. So the first thing that we did was sorting the array. So we have sorted our array. Then we need two array, right? And their length would be equal to array length. We also need index array. Its length will also be equal to array length. We need to fill dp array with 1. We need to fill index array with -1. And we need to create a result set, which is list of integer. We at the end we need to return a result. We also need two pointers. One is maximum size, that would be initially 0, and then maximum index, which would be -1 initially. So good approach to solve any question in while interview is like writing the basic code that you know. And now we'll do the computation. So we have to start from first our very first element till array length. We need to process all the elements behind it. So another loop, which would be starting from I minus 1 and going all the way back till j becomes equal to 0. Now we need to check if nums I mod nums 0 is 0 and dp of j plus 1 is greater than dp of I. If that is the case, then we need to update our dp of I with dp of j plus 1. And our index array also needs to update it. Index of I would be j. After doing this, we have to update our max also. So at the end of this loop, we'll check if our max is smaller than the result that we just calculated. If yes, then we'll update our max size and max index to I, element that we are currently processing. And in the end, we have to create a result. So we'll start with our maximum index. We will create a loop starting from max index and ending till I becomes 0. I is greater than equal to 0. And then we will simply put this into our result bucket, nums of I. And we need to update our I to index of I. I think we are done on the code. Let's try running this problem. Yeah, so our solution is accepted. We are done with this problem and we have passed all the 41 test cases. So in case you want me to try any other question, please leave out a comment in comment section and I'll give it a try. Thanks for watching this video.